Let's proceed to equilibrium of three-dimensional rigid bodies. Now, so you try to take note that a system in three-dimensional rigid bodies is in equilibrium if the resultant force is equal to 0 and the resultant couple moment is equal to 0. So we have 6 equations of equilibrium in the three-dimensional rigid bodies. First, summation of forces in the direction of x is equal to 0. Summation of forces in the direction of y is equal to 0. Summation of forces in the direction of z is equal to 0. And summation of moment about the x-axis is equal to 0. Summation of moment about the y-axis is equal to 0. And summation of moment about the z-axis is equal to 0. Now, in order for the rigid bodies to be in equilibrium, so this is, we have the different or the common types of supports and connections. Now, the common types of supports and connections used and their corresponding forces and moment used to represent the action of these supports and connection on the free body diagram are shown in the handout. So you try to look out your hands out regarding the different or the common types of supports and connections. So let us try to illustrate this one with the first example. So the first example in here is two steel pipes AB and BC. So this is your steel pipes AB and BC. Each having a mass per unit length of 8 kilogram per meter are welded together at point B and supported by 3 wires. So you have your TA, TD, and TC. Knowing that A is equal to 0.4, so the value of A in here is 0.4 meter, determine the tension in each wire. So we are required to determine TA, TD, and TC. So you try to take note in here now that the mass per unit length. Okay, so you try mass per unit length of A pipe AB and BC AB and BC is equal to 8 kilograms per meter. So it's 8 kilograms per meter. So first, let us try to determine now the weight of pipe AB and the weight of pipe BC. So I'm going to consider now that this is now the weight of pipe AB. So I'm going to consider this is now your WAB. And we have now your pipe BC. Of course, it's concentrated at the centroid. So this is therefore the weight of pipe BC. This is the weight of pipe BC. So we have WBC. It's acting at the center. So this one in here is 0.6. So this is 0.3. And this one in here is also 0.3. So this point, this is 1.2. So this one is 0.6. And this one is 0.6 meter. So first, let us try to determine your weight AB. So how are we going to determine now your weight AB? So your weight AB, the mass per unit length, is 8 kilograms per meter. So let us try to multiply this one by the length of AB, and the length of AB is 0.6 meter. Okay, so this is now meter and meter cancels out. So what is left is 8 kilograms. So that is still the mass. Let us try to multiply this one by 9.81 meter per second square. So we now have the weight of pipe AB is now equal to 47.088 kilogram meter per second square, or that is now your newtons. Next, let us try to determine the weight of pipe BC. So again, the weight of pipe BC is 8 kilogram per meter. Multiply this one by the length of BC, which is 1.2. Again, let us try to multiply this one by 9.81 meter per second square. Hence, the weight of pipe BC is equal to 94.176 kilogram meter per second square, or that is 94.176 newtons. Okay, let us try to take moment. If you try to get summation, so we now have summation of moment about the x-axis. So ito yung x-axis natin. This is the y-axis, and this one is the z-axis. About the x-axis is equal to 0. Let us try to take counterclockwise moment as positive. Okay. About the x-axis, your TD, TC, and WBC has no moment because they intersect the x-axis. So the only forces that we're going to have moment is TA and WAB. So TA and WAB. So your WAB is going counterclockwise, so we have positive. So that is your W. So that is going counterclockwise. So we have WAB. The moment arm is 0.3. That is 0.3. Your TA is going clockwise about this one. Okay. So it is TA minus TA. Multiply this one by the moment arm, which is equal to 0.6. And this is equal to 0. So WAB is 47.088. Multiply this one by 0.3 is equal to 0.6 TA. Hence, the value of TA is now equal to, that is equal to 23.544 newtons. Next, let us try to take summation of moment about the ZC axis. Okay, so let us try to, this is the Z axis. So, let us try to draw a line parallel to the z-axis passing through point C. So that is now our axis, say C. Okay, so this is now the axis, say C. Now, if you try to take moment about the axis, say C, then TC has no moment because it passes through, intersect this axis. So, the only forces that we're going to have moment is this one which is your WAB. So we have your WBC, we have your TA, and we now have your TD. So this is equal to 0. Again, let us try to consider counterclockwise moment as positive. So your WAB about the Z, okay, so that is counter. So WAB multiply this one by the moment arm, that is 1.2. And then we now have plus about the Z-axis. Okay, so that is counter plus WBC. Now, the moment arm is 0.6. And then your TA about this is going clockwise. So we have TA minus TA, multiply this one by the moment arm, which is equal to 1.2. So your TD is still going clockwise, minus TD, the moment arm is, okay, this is 1.2 minus 0.4, so we have 0.87, that is equal to 0.8. Okay, so that one is equal to 0.8. So we now have to multiply this one by 0.8, that is equal to 0. So we have 47.088 by 1.2 plus 94.176 by 0.6 minus TA, and that is 23.544 by 1.2 minus 0.8 T sub D is equal to 0. So we now have your 0.8 T sub D is equal to, okay, the sum, the algebraic sum of these three terms in here. So that is equal to, we have 84.7584. So your TD is now equal to 105.948 newtons. So next, let us try to take now summation of forces vertical, summation of forces vertical, or that is summation of forces in the direction of y, and that is equal to 0. So upward forces positive. So we have TA plus TD plus TC minus WAB minus WBC is equal to 0. So we have TA, that is 23.544 plus TD 105.948 plus TC minus WAB 47.088 minus WBC 94.176 is now equal to 0. Hence, the value of TC is 11.772 newtons. It's equal to 11.772 newtons. Okay, next, in the previous problem, summation of moment about the x-axis is equal to 0, taking counterclockwise moment positive. That is taking counterclockwise moment positive, then we get the value of TA, which is equal to 23.544 newtons. Now, supposing, let us not going to have moment about this axis. Instead, let us try to get moment about this axis, about the z-axis, equal to 0, and we have counterclockwise moment positive. That is counterclockwise moment positive. So about this axis Z. So that TA and WAB has no moment about the x-axis, about the z-axis, because they intersect this axis in here. So there are only three, TD, TC, and WBC. So let's start with TD. So TD is going counterclockwise. That is now your TD. The moment arm is 0.4. Next, TC is still going counter. So plus TC, now the moment arm is equal to 1.2. That is 1.2. And then we have minus WBC. So we have your WBC, the moment arm is 0.6, or that is 0.6, and this one is equal to 0. So we now have 0.4 TD so that's 0.4 TD plus 1.2 TC is equal to WBC, and WBC is 94.176. Multiply this by 0.6. So, in other words, your 0.4 TD and then plus 1.2 T sub C is equal to, so this is 56.5056. I'm going to consider that one as the first equation. Next, summation of forces vertical is equal to 0. We have upward forces positive. So we now have TA plus, you have your TD, and then plus TC minus WAB minus WBC is equal to 0. So that one is equal to 0. We know the value of TA, and that is 23.544. Plus TD plus TC minus WAB, 47.088 minus WBC, 94.176 is equal to 0. Okay, so that one is now equal to 0. So we now have your TD plus TC is now equal to the sum of this minus 23 point, sum of 47.088 and 94.176 minus 23.544, that is equal to 117.72. 117.72. So this is now your second equation. Okay, so at this point, solve equation 1 and equation 2 simultaneously. So your equation 1, is 0.4 T sub D plus 1.2 T sub C is equal to 56.5056. So we have equation 2. Let's try to multiply this one by 1.2. Okay, so we have 1.2 TD and then plus 1.2 TC, 1.2 by 117.72, that is 141.264. Okay, so let us try to subtract the two equations. So we have negative 0.4 minus 1.2 is negative 0.8 T sub D. That is 0, and that is equal to negative 84.7584. So negative 84 point. So it's 84.7584. Hence, your TD is now equal to 84.7584 divided by 0.8. So we have 105.948 newtons. Okay, so let's try to substitute TD in either equation 1 or equation 2. In here, I'm going to substitute. Okay, substitute TD in equation 2. So that your TD in equation 2, 105.948 plus TC is equal to 117.72. So your TC is 117.72 minus 105.948. That is 11.772 newtons. Okay, so that is the value of TC. Okay, next is problem number 2. Now, we have a rectangular plate of uniform thickness shown has a mass of 500 kilograms. So, the mass of the plate is equal to 500 kilograms. Determine the tensions in the 3 cables supporting the plate. So, we have cable A, cable B, and cable C. So first, let's try to draw the free body diagram of the plate. So this is, okay, before this is 2.5, this is 175.75 and 1. This one in here is 1.5, and that one is 1.6. So if this is 1.75, that is 1.5, hence this is equal to 0.25. This is 2.5, and then we have 1.6. This is therefore equal to 0.9 meters. Now, so we now have the free body diagram. So we have the mass of the plate is 500 kilograms. So the mass is acting at the centroid of the plate. So this is therefore your weight W. So your weight W, you try to take note in here now that this one in here is equal to, so 1.75 divided by 2, or this is equal to, okay, so this is 1.75 over 2, so that is 0.875. This is 0.875. So this is the centroid of the plate. So that is now your weight of the plate. Now, so this stands therefore in 2.5. Hence, this one in here is, okay, so we have it's 2.5. Hence, we have 1.25. Okay, so this is 1.25 and this one is 1.25. Now first, let us try to determine now the weight of the plate. So the weight of the plate is now equal to 500 kilograms by 9.81 meter per second square, or this is equal to 4905 kilogram meter per second square, or that is 4905 newtons. Next, let us try to take summation of moment about the x-axis. By this time, this is the x-axis. This one is the y-axis, and this is the z-axis. Summation of moment about the x is equal to 0, counterclockwise moment positive. TA has no moment because it intersects the x-axis. So we have your TB will have a counterclockwise moment. So that is now your TB or tension in B, multiply this one by 0.9. So we have the tension in C, a counterclockwise moment, so plus the tension C, the moment arm is equal to 2.5. So that one is 2.5. Minus W, that is clockwise, minus W, the moment arm is 1.25. And that one is equal to 0. 0.9 T sub B plus 2.5 T sub C minus 4905 by 1.25 is equal to 0. 0.9 tension in B plus 2.5 tension C is now equal to, we have 6131.25. Let's call this as the first equation. Summation of moment about the y-axis is equal to 0, counterclockwise moment positive. So this is the y-axis. So TB has no moment because it intersects the y-axis. So let's start with W is going clockwise about the y-axis. So we have minus W. Now the moment arm is 0.875. Okay, so we have your TC about, so your TC. So plus TC, counterclockwise moment by 1. And then plus T sub A, multiply this one by 1.5. And that one is equal to 0. So that minus W is 4905 by 0.875 plus TC plus 1.5 T sub A is equal to 0. So we have 1.5 T sub A plus T sub C is equal to, transpose that to the other side of the equation. This is 4291.875. So it's the 4905 by 0.875. This is now the second equation. Next, summation of forces in the direction of Z is equal to 0. Upward forces positive. So we have TA plus T sub B plus T sub C minus W is equal to 0. So we now have your TA plus T sub B plus T sub C is equal to W, and W is 4905. Okay. Now, from equation 1, 0.9 T sub B is equal to, let's try to transpose this to the other side of the equation. So we have 6131.25 minus 2.5 TC. So we get your TB in terms of TC, 6131.25 over 0.9 all over 0.9 is 6812.5. 12.5 minus 2.5 over 0.9 is 2.778 T sub C. Next, from equation 2, we have 1.5 TA, equation 2, so we have 1.5 T sub A is equal to 4291.875 minus TC. So that your TA is now equal to 4291.875 over 1.5 is 2861.25 minus 1 over 1.5 is 0.667 T sub C. So we now have the value of T sub B in terms of TC, T sub A in terms of TC. This time, let us try to substitute now the value of, so we have to substitute the value of TB and TA in equation 3. I'm going to consider this as the third equation. So we now have TA, and the value of TA is 2861. That is 2861.25 minus 0.667 T sub C plus your T sub B is 6812 point 6812.5. Okay, 6812.5 minus, okay, I'll erase that. Okay, 6812.5 minus 2.778 T sub C plus T sub C is equal to 4905. So it's equal to 4905. Now, so that 2861.27 plus 6812.5 and then minus 4905, so that is equal to 9673.75, and that is equal to T sub C. Minus plus 1, or that is equal to 2. So that one is now equal to, okay, so I'm just going to get this one in here. Okay, 2861 plus this one, so that is equal to 9673.75 minus 0.667 TC plus 0.2778 TC plus 1 is equal to minus 2.445 T sub C is equal to 4905. So your 2.445 T sub C is now equal. Transpose that to the other side of the equation, so it will become positive. So we have 9673.75 minus 4905 minus 4905, that is equal to 4768.75. Hence, the value of TC is 1950.409 newtons. Okay, so let us try to substitute now TC in equation 1 and equation 2. So, in equation, TC in. So, there's equation 1. So, this is your equation 1. Okay? And this is your equation 2. So, we now have TB is now equal to 6812.5 minus 2.778, and the value of TC is 1950.409. Hence, the tension in cable B is 1394.264 newtons. And then we now have your TA is equal to 2861.25 minus 0.667. The value of TC is 1950.409. So, TA is now equal to 1560.327 Newton. So those are now the tensions in cable A, cable B, and cable C.